Welcome back, guys, to these new sessions of the Journal Club. The speaker of today is Mahed Moussavi. Just a few words about Mahed. Mahed got his master thesis in computer science here at the University of Trento, and now is a third-year PhD student working in the research group of Giuseppe Riccardi, the Signal and Interactive System Laboratory. And his research are related to deep learning and natural language processing. And in particular, he works on knowledge-grounded dialogue system that is going to be the topic of today. So before we start, I want to say that since this is going to be a complete remote talk, if you want, of course, at the end, and if you have any question, you can turn on your camera and ask directly to Mahed. If, of course, Mahed, is it fine for you?
Absolutely.
Okay, so Mahed, the floor is yours.
Thank you. Thank you. I would like to thank Gianluca for the kind presentation. I would like to thank my friends in the structured machine learning group that prepared this platform for us to share our research and have a discussion about it. So yes, I am a third-year PhD student in the group of Professor Giuseppe Riccardi. We are working on dialogue systems. In particular, I'm going to present to you how we have been working in the last 3 years. What I'm going to present now is a part of my PhD, which is an ongoing research, but we have some interesting results. So let's discuss it together. So the topic of the presentation is, have we achieved personalized dialogue generation yet? So first, we need to see together what is natural language generation. What we mean when we talk about this concept. Natural language generation can have different forms. The first form that I would like to show you is data to text, like image captioning. When the input is an image and the output is a sequence of tokens explaining the picture. In this case, you would have to have a model that is able to understand the picture, comprehend the content, and then turn the meaning representation obtained from the picture to a sequence. The second possible example can be the table to text, which is a research topic by itself, where they try to convert the inputs and the data inside a table structure in a tabular format into a natural language output. Or the other one can be graph to text, which this graph can be either logical representation of events and probabilities, or can be a common knowledge graph representing relations between entities and participants. However, the topic of my PhD was mostly regarding text-to-text generation, where we have a sequence of tokens as an input text, and we need to convert to another sequence of tokens as an output, which is to be traditionally in the community, the concept was to convert a possible meaning representation, which was known to be the intermediate representation of the input, to a possible output, which is the sequence. And then there are properties of the generated output, whether it should be correct grammatically and non-grammatically, whether it should be appropriate, coherent. In some scenarios, it should be engaging. In some scenarios, it should be contextualized. And for the domain that I'm going to present now, which is more on personal dialogues, it should also have a characteristic which is listening. So in each part of the generation, you should show to the other side of the dialogue that you're listening to them. Now, an example of text-to-text can be summarization, where we have a huge amount of text which we can consider it as unstructured form of knowledge, and we need to have a summarized version. There are these two very informative animations that I took from a post on Medium. I forgot to cite, unfortunately, but if you search extractive versus abstractive, you can see the difference. The other possibility is story generation, which is now very attracting a lot of attention. And the concept here is that you have a possible story and you would like to generate the continuation. And this was basically, for the people who are not from the NLP community, this is very similar to what pre-trained language models do usually. There is a story or a news, and they are seeded with that sequence, and they are expected to generate the rest. Here, we can see that we have two options as generation and selection. The generation part is where we have to first comprehend the input and then token by token generate the response or a continuation which corresponds to the input. However, in the selection, we are selecting from a pool of candidates which is predefined to us either by the developer or the domain expert. And from that pool, you would take the most appropriate and most similar sequence that can represent the continuation of the story. The other example can be response generation, which is what I am working on and what you can see in dialogue systems. Dialogue systems like Alexa, Siri, Google Home, Cortana, all these systems can be considered as commercial dialogue systems that are now very popular, and we have it on our phones, on our smartwatches, on our computers. Though if you want to technically look at it, we can break them down to task-based, open domain, and question answering scenarios. Task-based systems are when the system is designed for a predefined task. When you call, for example, a flight booking system, the task is to book a flight, and the type of questions and the type of answers. So in a nutshell, the interaction with the system is limited and predefined to what it's designed for. However, the open domain dialogue, as its name suggests, it is more than a task, and it is a chit-chat. It is a socializing conversation. While question answering, as the name suggests, is about answering a possible question that the user asks. So if I would like to position Alexa or these commercial systems between in these categories, I would say that such systems are designed for task-based, like setting an alarm. I'm sorry, my Alexa started talking, so let me disconnect it because I said the name twice. It decided to intervene. I was saying, so if I would like to position Alexa or Google Home in such categories, I would say that they are mostly task-based systems. When you ask it to set an alarm or to ask it to set a reminder for you, while they would also handle information retrieval and open domains. So it's not purely question answering, but it's not very much open domain also. Now, all these, we can also look at the possible response generation based on the policy rather than the domain. From the policy point of view, it can be either selection from a pool of candidate or a generation, or probably a template also. Now, I am showing you two possibilities for selection or generation. For the generation, you need to encode and decode a possible response, while the selection, you would just, based on the context and the pool of response candidates, you select the most proper one. So now that we have gone together through the whole concept of generation and natural language generation and response generation, let's think about what is a personal dialogue generation. While dialogues in the community, dialogues that have been studied so far are about possible tasks or a chit-chat, personal dialogues are conversations that they encompass personal feelings and events. They talk about the space of the user with its participants that have probably activated the user's emotional state, and they represent the real life of the user. They can be seen as possible narratives that we talk about to a friend or to our parents, where we describe a possible event that during the day it made us very happy or very angry, a possible interaction with the person. So in order to be able to interact with the patient, with the user in such dialogues, in order to be able to generate a coherent response through the beginning till the end of the conversation, we need to have certain properties. So we need to first hold a dialogue about such events and relations and participants, which is absolutely different from a possible flight booking or restaurant booking. Moreover, it's also different from a possible chit-chat when there is no objective at the end. Meanwhile, what happens in personal dialogues, which is currently not touched by the research, is the idea of multi-session conversations. Most of the systems that we already interact with in our daily basis are designed for standalone sessions when you ask a task to occur and it happens and it is lost. When you ask a question to your Alexa system, it answers you and it is lost. There is no follow-up with the system. The system doesn't come back to you over a longitudinal manner to ask you how it went or how did it end up. So we need to have multi-session conversations. Moreover, while for many other scenarios like question answering or like a task-based system, there is always a general purpose knowledge base which can serve as a knowledge base for our dialogue. For a personal dialogue, there is no such dialogue. There is no dialogue base, dialogue data, domain data that can serve for all possible users for personal conversations. So what we need to do is to obtain such knowledge during the interaction with the user and from her narratives and from her own turns during the dialogue. So the first thing we need to discuss is that we need dialogue data. We need domain data. The acquisition of dialogue corpus is a key step to train a dialogue model and to evaluate it. As I anticipated to you, such data in the available currently in research is either for open domain information retrieval for a selected set of topics or slot filling and task-based scenarios. But these cannot answer the need for personal conversations when the user is talking to us about an event that has emotionally activated him or her, including participants and entities in his real life, and there is no data for that. So during our research, the first thing we did was to propose a novel methodology to collect a data set of narratives, personal narratives, followed by follow-up dialogues. These dialogues are possible follow-ups that a friend or a therapist or a person who cares about the speaker would ask the day after or maybe a week after. So how did it go about your exam? What happened to your, visa application? What happened to your PhD application? These are the questions that you would follow up with the speaker when he shares with you. In this data set, what we first did was to collect around 200 personal narratives. The users who would come to us and explain an event as if they're explaining this event to their therapist or to their friend about an event that has activated their emotional state. So the idea of arguing with their parents, the idea of fighting over phone with their boss, the idea of getting either super happy or super sad about such event. And then using that, we automatically converted these narratives into possible stimuli. A stimulus is what initiates the dialogue. When I ask you, so how did it go with the conference you had to participate last week? This is a stimulus that is triggering a dialogue between you and I regarding the event that has activated your emotion. And then we have recruited therapists and dialogue experts as dialogue writers to impersonate themselves as both sides of the conversation to write a follow-up dialogue to respect these properties. Using this work, which was published in a workshop in NACL last year, we collected 800 dialogues, which they all started with a stimulus. and they ended with a closure. The closure was very important in our setting because it was somehow working as a possible grounding between the two participants, between the two sides of the conversation. And it was we suggested our annotators to almost always include a suggestion for relaxation or for improving the emotional state of the user. And then, as I told you, since there is no general purpose knowledge base to serve such setting, we realized that we need to have narrative understanding. We need to have a model who can extract such information during each interaction with the user. And the reason is that the narratives of the users has a complex structure. It insists of events and participants, and it is way more difficult than dialogue act tagging or intent classification and slot filling. So we realize that we need to construct the personal space of each user from their own narratives during the dialogue. And the word personal space gave the name to its model that we developed. So what we developed was it was a baseline. Currently, we are working on improving it. It is an unsupervised approach, a rule-based approach, which automatically extracts personal life events and participants from user narratives and represent it as a personal graph. This graph is then updated at each interaction with the user. So for example, when I ask you, this example is in Italian. I apologize to the participants who are not Italian speakers. But for example, when I ask the user in the first note, what did you do yesterday? And she tells me, I took my laptop to the office. My laptop was prepared by the technician, and I really love my laptop. I need it very much. This would create a graph which the user is represented as EO or I, and then the technician and the laptop are participants, and the verb that is between these two is representing the event that has occurred. This work is we were inspired by two papers by Juravsky in 2008 and 2009 that was considering the concept of the verb as the event and the subject and the object of the verb as a possible participants. So this personal graph is created at each interaction, as I told you. What we did, like our novelty, was to first show it as a graph rather than just a list of unordered events. Second was to give importance to possible events. As you can see in the picture, each edge is labeled by an index. This would give us the ability to understand the sequence, to reconstruct the sequence of events after we have constructed the full graph. And last but not least, it would give us the idea to automatically realize and conclude which event is activating the user's personal emotional state. Now, currently, we have published this work. It was a master thesis that I co-supervised last year in ClickIt. Currently, we are working to improve this graph and to have a data-driven model that can extract this graph. And probably also we are working on embedding the emotion. So not only it's the event, but we would also know which event activated what type of emotion. So having this data and having this event relation extractor, we also looked at the concept from another point of view. There's this concept of emotion carriers in the linguistic community, which explains that emotion carriers are words that by themselves, they might not have a sentimental polarity, they might not manifest an emotion, though implicitly they express an emotion in the text to the speaker. So in the example, I experienced a bit of stress in the office. The emotion carrier is the office, which by itself is neutral, while to a possible speaker, to a possible narrator, can represent positive or negative idea. When if you don't like your job and you come to me and say, you know what, yesterday I went to the office again, I automatically know that something bad is going to happen because you are going to a place that negatively activates your emotional state. While the emotion-laden words are the words that explicitly and clearly manifest an emotion. So what we did was to first understand this concept and try to be able to first have an emotion carrier recognition model, as well as valence or sentiment prediction model, and try to look at it from another point of view. Try to look at it to understand whether we can understand the emotional state of the user using its emotion carriers. And I would like to suggest that these emotion carriers are mostly reoccurring in the personal graph as well. So the joint would be a system that the emotion carrier would represent a polarity, positive or negative, which would affect the space of the user, which would be used to infer the next turn in the dialogue. And this was another work which was highly appreciated. We are going to have a lot of follow-ups on this because we realize it's basically what's missing in this area. So what we did first was to use these models, all these models, and develop a retrieval response model, which, as you remember, was trying to select the most appropriate response from a pool of candidates. We deployed this model, this response selection model, into let's say studies, into trials, which one of them was a randomized controlled trials with real patients, and we recruited actual psychologists. And in the papers that we published, we represented that using the PHA, using the personal health care agent, which is able to have even selection-based responses which are personalized and contextualized, had helped to reduce the trends related to distress and anxiety of actual patients. And the therapists engaged also showed interest very much about this blended intervention, where the user could talk to the PHA, to the system that we designed as a dialogue system, which was, again, I specify it was a selection based. And then the dialogue with the system and the whole interaction with the user would be a tool for the therapist to see how much, first, personal it had gone to be, and second, what are the events that has activated the user's emotions in order to provide support appropriately. Then this is which I'm going to skip very fast, but I would like to show, this is the structure that we prepared for our system compared to a task-based system. When we have slot filling and intent classification, this was different. Here we need to have a model that is able to create the personal space graph of the user, another model that was able to hold a follow-up dialogue with the user every once in a while about the event that he has described previously, and then probably at the end the response selection model, which would rank the possible candidates by coherence and then output them. All in all, the idea of generation is way different than selection, as we know. So what we did after this selection model was to experiment with generative architectures. These possible candidates for generative architectures in our data and in our setting, since it's Italian, are T5, which for the participants, I would like to shortly explain. T5 is a pre-trained language model which consists of the encoder-decoder of transformer architecture, and it can serve for several tasks once it's fine-tuned for each task specifically. The other candidate is Gepetto, which is GPT-2. Compared to T5, GPT family, they only consist of the decoder of the transformer, and they use a tokenizer, which is byte pairwise, as a possible, let's say, encoder, which is not basically an encoder. It just maps the sequence of tokens to the search space. So the first thing that we can do is to just dump our beautiful data and start fine-tuning these monsters and see what happens, which would be the first thing to do. However, the issue is that when we are talking about personal dialogues, it is more difficult because the training and developing of personal systems is subject to accuracy, appropriateness, and acceptance by the user and ethical compliance. A data-driven model, as we all know, sequence-to-sequence models, they suffer from issues like toxic responses, unethical and biased outputs, and they can be dangerous. If the user comes to our system and express his sadness, the system cannot answer in a very inappropriate way. An example that I would like to give you, it's a short memory. In these randomized trials that we did, we had this selective system, and at a certain point, the system has called one of our patients Signor Fantozzi. And this created a big issue for us because for the people who do not know the story, Signor Fantozzi was a character in Italian TV, which is represented as a funny comedy series, which this guy has always problems. And our patient was seriously offended by being called Signor Fantozzi. And I would like to say this happened in a selection scenario. So let alone what would happen in a generative one. So here, since the issue is more than the personalization should be much further than food preference or pronoun selection, we need to be more careful. We need to be able to handle such toxic outputs. Though the issue that is basically limiting us is that these systems, due to their nature, are not explainable. It's very hard to control their output. So the possible solution that is happening now in the community is grounding the responses of the system. What happens is that instead of one input vector, which is the dialogue history, the model is trained by conditioning the generation on two different input vectors. One of them would represent the dialogue history as a context, and one of them would be another sequence which is supposed to limit and ground the system further. In the papers already published, it had been always either a Wikipedia source or a piece of knowledge about the exact particular concept of the conversation, the topic of the conversation. Currently, we are, this last slide, I would like to spend time and explain what I am doing now, basically. Currently, I am working on grounding the personalized responses of the system on two input vectors. The first input vector would be the terms that the user has explained. The dialogue history would be the terms that the user had given us as any classic dialogue system, while the first one would be the personal space graph that we have created with our model, which represents in a very distilled, in a very reduced format, the space of the user's real life events and their participants. We have preliminary results and they seem promising, but as you all know, automatically evaluating dialogue systems is not a good idea. So currently we are deploying human evaluation tasks. We are still working on it, and I would like to one day share with you and say if it actually worked or not. So this was my presentation. Thank you very much for your patience, and I am happy if I can answer any of your questions.
Thank you, Maed, for the presentation. So, question now from the audience.
I do have a question. Actually two, but maybe I will start with the non-technical one. It seems that the human factor is prominent in this kind of research, and not only from a patient point of view, what I mean is like you not only apply the tools that you develop and deliver them to people that are gonna use it, you have to deal with many other human factors. And I was just curious if you would like to share a bit of your experience. And because when we do research, or at least when most of us would have do applied science, uh, give for granted to have data sets, and they like to have data sets that are very clean, and they don't actually see the whole context where those data sets have actually been produced and the amount of work that actually this involves. So I don't know, I would like to hear from you what was a bit of your experience and what it actually involves to collect this kind of data and the whole pipeline and the process. And yeah, mostly from the
Uh,
training.
Thank you. It's a very interesting question, and you are absolutely right. So I would like to go to the beginning. So as you said, it's absolutely true. My research, I was lucky to do this research in the platform of a European project, which was called CoAdapt. I started from zero, basically. So we didn't have data. So we had to collect data. We had to recruit dialogue writers. And we had to train these dialogue writers. We had to prepare dialogue annotation guideline. We had to train them. We had to have several meetings with them. Once we did this, we then had to train the therapists how to use this system, how to interact with the user, what this system, because also there is always this negative stereotypical mindset that AI is here to rob us, steal our jobs from us. So we need to also explain to the therapist that we are not going to steal your jobs. This is going to be your help assistant. And the other thing is that if this in this picture, I didn't mention for the point of matter of time, but since it was very important that we were dealing with actual patients and actual therapists, we had to have always a psychologist in the loop with a very low latency would first approve each response of the model. Of course, we had rejection in a very low ratio of the output, but the idea is, and then I'm going to spare you the fact that each of these 2-3 trials that we did, we went to the ethical committee, we got approval. If you read my papers, there is always this footnote that the data collection was approved by the ethical committee of University of Toronto, because everything we did was very much with sensitive data. In fact, it was one of the difficulties. Perhaps if I was working on a dump of Wikipedia, I could have results way faster and way easier. Thank you.
Thank you very much.
May I follow up on this question regarding the dataset? What's the size of it? This is one question. And the other question is whether, so if I understand correctly, you have different people, like, and the identity of the people is important. So have you also annotated this information in the sense that, do you know which people have already interacted with each other, and are there dialogues among people who have interacted more often or less often, and things like this?
So I start from the first question. The size is 800 dialogues consisting of 3,200 dialogue turns, and the length is around 20 tokens per turn. So it is not huge. It's, let's say, a medium size, but it was our experiments. We realized that
800.
800 dialogues, yes. In our experience, we realized that it is enough for a response turn-based fine-tuning. This is the first thing. In order to generate this 800, we collected 200 personal narratives from 20 patients. The narratives were collected in the setting similar to the Ulm dataset, I don't know if you know, or Stanford emotion dataset, where people are asked to express, to narrate 2 positive events and 2 negative events that have activated their emotional state. In this setting, we developed a dialogue state machine, which was just a finite state system that was also just asking questions to the user, and the user would express their emotion and explain an event that triggered that emotion. Those narratives were then used to collect 800 dialogues. We had 8 dialogue writers, of which 4 of them were therapists. So basically, I can say each dialogue is written by a different person and it is representing different events and participants.
So each dialogue, but it's a follow. So it's not an actual follow-up.
Not an actual follow-up. No, it is an impersonation that the therapist.
Okay, I see.
Yes.
Because I mean, I have that. There is this work done by the group led by Goodman at Stanford, and they nicely apply continual learning methods among to model this adaptation that happens between interlocutors.
Yes.
So when you have two agents, two people that speak to each other, they tend to adapt to find languages, that they converge towards the kind of conventions they use.
Yes.
And they try to model this using the continual learning methods of some laws that are used by the continual learning community. So I find that idea is brilliant, and I thought that I could nicely merge the people that are in this room because as far as I know, you are working on continual learning. And I was wondering, but for that, indeed, you need to have. So they train the model on. They train the model like this. Now they have two agents that speak to each other, and they have the speaker and the hearer, and the speaker learns and is updated, continues through different trials of interaction with the hearer, and is updated with the hearer success. Or
yes.
So they mimic this follow-up iteration, basically.
Yes, I have not read this exact paper, but this is very interesting. But I think it's not applicable to our setting because there is one follow-up over narrative. However, something that I didn't mention in this presentation is that I am also in parallel working on human-human dialogues, which are therapist-patient session recordings. During our randomized trials, we collected around 700 therapy session recordings, which are human-human dialogues. There we are working on continual learning and also to see how longitudinal, let's say, approaches would show the trend on the user and the concepts that are discussed with the user. In this regard, Rada Mihalcha has from the University of Michigan has worked a lot on such concepts. I am working on trying to model the user in a longitudinal manner from these human-human conversations, but this is still not enough to be presentable, let's say, because I'm still at the
Okay.
Thank you for the question.
Yeah, I share the link of one of the author. I don't recall now the exact title of that.
Oh, thank you very much. Yes, I see it in the chat. Thank you. Yes, I open it immediately not to lose it.
Well, I leave space for a question.
Do we have enough other space for other questions?
Yes. We have space.
Maybe Rafaela wants to go. If he has a question, then I might ask one.
No, just go ahead. I took space already, so.
Thank you very much. Yeah, actually, I forgot to thank you for the presentation. It was very interesting for me. It's very interesting work. I have on the last part that you're currently working on. Did you notice, because these generative models that digest text and they have to again output text, do you happen to see any kind of hallucination problem where
yes,
the model starts embedding things that it didn't even see in the history or in the personal knowledge part that I see in your input? And if you have a way, I don't know, to guide this, I guess it's very difficult to
yes,
put something right to the generation part, or is there any prompt that you tried and see like, okay, with this prompt now that I prepend or I append, now the model is more, I don't know, more conservative, or it outputs more factual,
Yeah.
for more factual things instead of hallucinating new things that he never said.
Yes. Thank you for this question. This is what I have been basically noticing in the last 2 weeks. So what I first did was to fine tune the model without the knowledge vector, only on dialogue history. And then I fine-tuned the model with different representation of the dialogue history. If you read the grounded response generation community, the first representation everyone uses is the unprocessed full sequence, which I called it the raw representation because it was uncleaned and unprocessed. I realized that, and then I would like to also say, I did also the personal space graph, which as I showed you, was a linearized event participant sequence. Now, automatically, when you evaluate by perplexity, BLE 2, 4, you don't see anything clearly. But during my human evaluation, one of my questions was, is the response contextualized or not? And then I asked the annotators to tell me what type of wrongly contextualization they are observing. I realized that around 70% of the responses of the grounded system, so the system that had access to the knowledge vector, was annotated as the response is referring to a person or object that does not exist in the dialogue history. Further analysis, I realized the huge problem of hallucination. So what happens is that the model, the output is like, hai provato a parlare con il tuo capo, which is absolutely irrelevant. But in other dialogues, we had people that had problems with their boss. And when the system is talking about, is handling a dialogue which is about an issue with the husband, it suggests, did you try to talk to your boss about it? You can see the hallucination here, which is referring to a possible knowledge which has been during the training, but is not actually valid. And interestingly, I saw that this amount, the amount of hallucination in the model, is proportionally connected to the amount of generic responses the model outputs. So grounded responses generate less generic outputs, but more hallucinated. Non-grounded responses generate more generic output, but less hallucinated. And this showed, in fact, I am working on this to probably publish this work. This showed how the limitations of these pre-trained language models at the end are still there, because in the community, grounding is considered as a possible solution. We realize that it's not true. It solves an issue and opens the door to possible issues.
Thank you very much. That was a very interesting analysis. Yeah, I guess it will be definitely useful to kind of report those findings, because, yeah, as you said, I mean, the model has been trained on some specific domain, and you probably want to fine-tune it in another domain.
Yes.
Some kind of different prompts that.
And then another thing I would like to tell you is that I realized that Geppetto is less, GPT-2 is less hallucinated than T5. During the studies, I realized since there is no encoder in the picture, the whole vector, which is the knowledge and the input, is given to the decoder by equally presented between the quotes and quotes. While T5 first encodes, so obtains a representation, then passes it to the decoder, which makes the system a bit more hallucinated, let's say.
Thank you.
Matt, sorry, I have a question. If you can say a few more words about how you encoded the personal spacecraft into, let's say, the prompt to the system, Geppetto.
Yes. So the thing that for grounded response generation, you just extend the input vector, and by possible special tokens and tags, you just attend or append to the tail, to the head, the knowledge vector. Here, since I had a graph, my idea first was to embed it using a graph neural network. In fact, I talked to my friend Antonio, which is working off graph neural networks, about how to possibly encode it. Then I read this paper, which I have cited in this work. It was published in INLG conference, if I recall correctly. It presented that for graph-to-text generation using pre-trained language models, a correctly linearized graph can outperform or perform as well as graph neural networks. What happened was the idea there was that you need to each branch, each edge and node, you need to correctly take it and add specific tokens and represent it in a sequence which responds the sequence of occurrence of edges. And the paper, of course, explained how to do it, prepared a schema and everything, and showed that by correct tags, because at the end of the day, these tags would help the model to learn that the entropy, so the information is between these two tags, and these tags, the entropy is 0 because it is seen very often. So I got inspired by this paper and I did this. So if you read this paper, you will see how to linearize a graph. I simply linearized my personal graph at each turn. So the graph consists of the user input till t-1. For turn t, I linearized it and gave it as the part of the input knowledge to the input vector for generation.
I see. Okay. And so you said that you include just the last step proportional space graph, or you linearize the entire graph so far?
And so far, I did the entire graph because my dialogues are 6 turns. So it's not huge. But as I was explaining to Professor Bernardi, for human-human dialogues, which they are 1-hour therapy sessions, I'm still working on it. I still don't know how to embed, because as you know, pre-trained language models also have an input length limitation. So I need to come up with possible truncation or explanation of the graph. As I showed you earlier, the graph we created also have the sequence of occurrence. So one idea is to look at top n events based on free occurrence, or top n events based on being the most recent ones. But still, I unfortunately, I don't have results good enough to present. It is still at, let's say, working level.
I see. Thank you.
Thank you. Thank you for the question.
Yes. I think that you have a question, Emanuele?
Yes, yes. It's a very small question, and thank you for your presentation. You were telling me that you had some work with explainability,
Yes.
and I was thinking, do you see a way to explain why the model is failing when, say, Mr. Fantozzi has a response? So it will be something related to, in your opinion, to I don't know. It seems very difficult to explain why a wrong behavior like that could happen. What would you look at?
So,
in your yes.
So in that scenario that Senior happened, the reason it was a selection system. So this sentence was already written, it was not generated, and the model selected that system. I dig into it, in fact, and I realized that the issue is because of the fact that the rest of the sentence are tokens that semantically have the most amount of similarity with the context. So what happened was that the model, because the rest were good, the model took the whole response and output it. because at the end of the day, we're looking at the semantic similarity between token to token. No, if you tell me today is very hot, and I tell you in Norway it is very hot too, this is an appropriate response because I am confirming that it is hot, but it is inappropriate because we are in Italy and I'm talking about Norway. So a system cannot understand this big issue, which for us is very, let's say, common sense. There was a selection, but in generation scenarios, at the end, what we know is that such models are just mirroring the distribution of occurrence of tokens they saw in the data set. So far, it has not happened in the generation setting, so I cannot tell you what we need to do. But in selection, it was just because of semantic similarity.
Okay, I see. And yeah, it would be also very, very interesting to embed that with you know, emotion carriers, and also to graph-based explanation would be, I mean, this is a more a suggestion. I think it's very interesting.
Yes, this is a very good suggestion. In fact, this is what I am currently working on with a visiting researcher that joined us from Japan, Nara Institute of Technology. The idea is to be able to embed emotion barriers and emotional states in this graph. So it can show us that, for example, this specific participant activates negatively or positively the emotion of the user. And then we can, of course, model his space much better.
Yeah. Very nice.
Thank you for the interview.
Okay, I think that if there are no more questions, we can. You have another.
If we have 2 minutes left, I would like to ask a further question. I hope that will be
Yes,
quick.
you have 4 minutes.
Okay, so I will be quick. My head, if my mind supports me, you said that it happened that for an input sequence like I'm having trouble with my husband, the system, the generator system, outputted like did you try to talk with your boss? And you, if my mind supports me, you said that it was due to the fact that the in-office problems were more often than, say, problems with the husband. So do you think that it could be a solution somehow to, instead of generating the input sequence that will be fed to the user, to, let's say, generate a sort of placeholder for the subject or the object of the response, so that instead of saying, hey, did you talk to your boss? You say, did you talk to placeholder? And then the placeholder is filled with, let's say, something that comes from the dialogue history directly.
Very good question. Can you still see my screen?
Yes.
Okay, so I'm going to share with you, I'm sorry, I'm writing in Farsi, my native language. So I'm going to share with you this paper that is basically answering your question. It is published in NACL 2021. What they do, Steve, is to, I think it is this one. No, it's not this one. I will share it with you after the call. What they do is basically the idea that the output of the system is not lexicalized. So the model outputs a template that does not include subject, object, and is gender neutral. And then there is another model that fills in the blanks. And this, yes, is an idea that's very interesting and is already being studied in the community. And they are doing it in this paper with a GPT-2 for English.
Okay, that's good. Thank you. For me, it's very enough.
Okay. So thank you again, Mahed, for the presentation. It was interesting. And I think that if there are, maybe we can have still time for a quick question, I think, if you have some question, of course. Okay, maybe I have a curiosity. You know, there is one of the hot topics now is the integration of sub-symbolic and symbolic reasoning, that is also known as neurosymbolic integration. Are you aware of any approach that, neurosymbolic that is applied in your domain? Do you know?
I am not sure about neurosymbolic, but I have seen also this week the ACL conference that was happening in Dublino. There are several works that are trying to teach the model logical reasoning. I can send you these papers after this call, but I am not sure about the type of reasoning they do. But I would like to say that so far in our community, reasoning was considered something implicit and in background. Now they
Because
are,
you know, no, go.
now they are trying to enforce it even further as an actual task of the neural model before generating the response.
Okay, because I was thinking that you know, when you have a logic layer, maybe it can help you to avoid the bad response, let's say. Okay, I was thinking,
Yes.
and
Yes.
it was just a curiosity. Yeah.
Yes,
So,
it can help you to answer with a better response. Also, we have this issue which is called ambiguous request. So you come to me and instead of saying I want a glass of water, you tell me I am thirsty. As a human being, I understand that I have to provide you water, but this is considered as an ambiguous request of the user, and they try to teach the model using logical reasoning how to answer these ambiguous requests.
okay.
I will share with you the papers, and I will also share
Okay.
it after this call.
Yes, thank you. So yes, I think that we can close the meeting now. Thank you again, Maed.
Thank you for the opportunity, guys.
So guys, see you in I think 2 weeks. Have a nice enjoy the rest of the day. So let's say
Thank you.
Thank you.
Bye. Thank you.
Thank you, Matt.
Thank you.
Bye.
Ciao,
ciao guys.
Bye bye. Thank you.
Bye.